In this lesson, we are going to learn how to graph hyperbolas. We will also make the connections between hyperbolas and ellipses, their similarities as well as their differences. And as you can notice from this particular picture on our first slide, in order to get a hyperbola, we have to have two cones end to end touching one another, and we have to make a vertical slice between the two cones, and that's how we get our hyperbola shape. So just a quick review of ellipses. We are given an ellipse in general conic form, and you can kind of think of this as the really kind of messy, slappy form. It doesn't tell you any of the information that you need in order to graph the ellipse. So we're going to change it into standard form, which we dealt with quite a bit in the last few lessons. So in order to put this into standard form, we are going to group our x and our y terms together and set the entire thing equal to the constant value so that we can combine our like terms and that we can complete the square for each the x and the y terms. So now that our x's are regrouped, I'm going to factor out that leading coefficient of the x's. So I'm going to factor out a 9, and that will give me x squared minus 6x plus, I'll complete my little square. For the y's, now that I have those grouped, I'll factor out that leading coefficient of 4, which will leave me with a y squared minus 2y plus my term to complete my square. And that equals the 59 we added to the other side of the equation plus 9 multiplied by whatever I complete my square with for the x's plus 4 times whatever I complete my square with for the y terms. So when we complete our square, we take half of the b term. So for our x's, we're going to take half of negative 6, which is negative 3, and then we will square it to give us 9. So we're going to have a 9 in each of those little terms to complete our square for the x's. For the y's, we're going to take half of our b value, which is negative 2, and we get negative 1, which we then square to give us a positive 1. So I'll add that to the other side of the equation. And you'll notice that we have 9 times the x squared term plus 4 times the y squared term, and that equals 59 plus 9 times what I completed the x squared for the x's plus 4 times what I completed the square with for the y's. So we're going to take it back down into factored form. We created a perfect square so that we could write it as a perfect square in factored form. So x squared minus 6x plus 9 is x plus 3, that quantity squared with the GCF of 9 out front, plus 4 times the square of our y's. So y squared minus 2y plus 1 factors to be y minus 1 quantity squared. And this will equal 59 plus 9 times 9 is 81, plus 4 times the 1 is 4. And when we find the sum of those terms, we will have the entire equation equal to 144. Now, this is not perfect yet because we do not have our equation set equal to 0. So we're going to divide every single term through by that constant value of 144. And these do reduce nicely. So 9 and 144 are both divisible by 9, which will leave me with the denominator of 16. So we'll have the quantity of x minus 3 squared over 16 plus the 4 and the 144 also simplify nicely to give us 36 for our denominator. So we'll have y minus 1 quantity squared over 36 all equals 1. So our final equation is x minus 3 quantity squared over 16 plus y minus 1 quantity squared over 36 equals 1. And from standard form, now we can determine our center. We can determine whether it is horizontal or vertical, our a and b values so that we could sketch a graph, as well as determine foci, vertices, and covertices. And now we're going to talk about our hyperbolas, and we are going to make connections with them and the ellipses. You'll notice that they have a very similar definition that we had for the ellipses, but our graphs are different. So ellipses, the two shapes would kind of go together because they're being added together, whether they are vertical or horizontal. Kind of think of two mini parabolas. But the hyperbolas are going opposite directions. So in order for it to be horizontal, I'm going to have x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. So again, that is to make a horizontal hyperbola. You'll notice that our curves are out on the left and the right hand side, and it is horizontal because the x squared is first, which is positive, and over our a squared term. In order to do that for the vertical example that we have, we need to start with y minus k quantity squared over a squared minus x minus h quantity squared over b squared all equals 1. So it's a similar formula, but in order for it to be vertical, it has to have the y squared term first as well as positive, and your a squared will be first as well. And that's the similar set for our horizontal ellipse. We have to have the x squared term to be first as well as being the positive term, and again our a squared is under that very first term. Okay, so the direction of our graph is determined by which variable is first. Is it the positive x squared, or is it a positive y squared? Remember, one of those terms will be negative. The distances between our a and our b and our c values satisfy the equation c squared equals a squared plus b squared, because when we graph a hyperbola, the two foci points are now on the outside of our hyperbola. Remember, it's got to be focusing on that particular point. So we have to change our equation for that. All right, here's our first example. X squared over 64 minus y squared over 36 all equals 1. We're first going to determine our center. That follows the same format. It's always the opposite of h, comma, opposite of k. There are no terms in parentheses with our x and our y, so our center is very nicely at the origin. That's going to make life a little bit easy for us. We are going to determine whether it is vertical or horizontal based upon our a squared term. So our a squared is always first, which is under the x squared. So this example is going to be horizontal. So a squared is under the x squared, and x squared is first and positive. It has to be the positive term. Okay, so if our a squared is under the x squared, we know that our a value is going to be the square root of 64, which is 8. Therefore, our b value, b squared, will be under the y, so our b value has to be the square root of 36, which is 6. Just like we've done with ellipses, we are going to use these two values of a and b so that we can sketch our vertices and our covertices. Since this one is horizontal, we are going to travel 8 units to the right and 8 units to the left and plot our two vertices. And you can make a note of what those are. So they are the points 8, 0 and negative 8, 0. We are then going to plot our covertices by traveling 6 units up and 6 units down from the center. So our covertices will be at the point 0, 6 and 0, negative 6. So coverts are 0, 6 and 0, negative 6. And now, in order to determine the slope of the asymptotes as well as the foci, we are going to use our a and our b values to help us get the slope of the asymptotes as well as then determine our foci. So what we're going to do is we are going to look at the distance that we traveled. Remember, slope is always your rise over your run, or the change in the y values divided by the change in the x's. So from the center, I travel up in this case, 8 units. Excuse me, 6 units. Excuse me, 6 units. So that is the change in our y's, so positive 6. That's also our b value. Okay, and then from there, in order to get to a vertice, to get to that corner where those two places would meet, I have to travel 8 units, which is our a value, to the right or to the left. So our slope is going to be positive and negative 6/8, or positive and negative 3/4. So when we sketch our asymptotes, we are going to start at either a vertice or covertice, whichever you choose, and we are going to draw a little box to connect each of these so that we have a nice rectangle. Just lightly sketch that. And we want to go from the center through the diagonals of each of these corners of our little box that we drew as best you can. It's better if you have a ruler for it. It makes it look a lot nicer. Okay, and so from here, that's another way we can look. We traveled up 6/8 to get to that corner of any of the places where our asymptotes land. And we can go ahead and sketch our hyperbola. So from the vertices, we're going to curve out and try to touch those asymptotes, get as close to them as you possibly can without touching. And there's our graph. The only thing left that we need to do is determine the foci. So remember, it is c squared equals a squared plus b squared. Our foci are the points from the center out past, in this case, the vertices. So c squared is going to be 64 plus 36. So our c squared value is 100, which means that c is both positive and negative 10. So we would travel 10 units to the left and put a foci, and 10 units to the right and put a foci, or a focus point. So technically what we're doing is we're taking our center, which is 0, 0, and we are adding 10 and subtracting 10 units to the x-coordinate of the center. So just to get a feel for it, it's 0 plus or minus 10, comma 0. Now, of course, we would rewrite that as positive and negative 10, comma 0, unless you wanted to write it as 10, 0 and negative 10, 0 for your foci. So that is our first hyperbola. We determined the center, the direction that our graph opens based upon that first term, whichever squared term is positive. A squared is always first, so our a value is first, and we'll take that square root. Determine our b from the b squared. The slope of the asymptotes is always our rise over our run. So b over a or a over b depending on the problem. And then we use our equation for the foci in order to determine that distance of c so that we can plot our foci. Okay, in our next example, we have y squared minus 4x squared equals 4. Remember, in order to graph a hyperbola, we have to have the entire equation equal to 1, so it's almost in standard form. We're going to divide each term through by 4, so we'll have y squared over 4 minus x squared over 1. You can put the 1 there if you need to see it, equals 1. And again, our center, we're keeping it kind of simple, starting off with the origin as our center, 0, 0. Nothing in parentheses with the y for the k value, nothing in parentheses for the x for the h value of our center. In this example, our graph needs to be horizontal. And the reason it's horizontal is because the a squared is underneath the y squared, which is both first and positive. So if our a squared is 4, that means our a value is 2. So from the center, I'm going to travel up 2 and down 2 and get the two vertice points of 0, 2 and 0, negative 2. I'll then do the same with our b value. In this case, our b value, let's see, b squared is 1. So that means b is 1. So I'm just going to travel to the right one and to the left one of our center in order to get our covertices. So the covertices are at the point 1, 0 and negative 1, 0. And we're just going to lightly sketch our little box through each of the vertices and covertices to make that little rectangle for us so that we can get our asymptotes. Remember, we're going to go from the center through each of the corners of our rectangle so that we can sketch our hyperbola through those particular points. Or excuse me, approaching those asymptotes through our vertice. Let's be precise. Okay, so remember our vertices are at the top and the bottom. This one is vertical, so I'll draw my little U shape up on the top, approaching the asymptote, and I'll draw it on the bottom, approaching the asymptotes as well. Okay, and to determine the slope of our asymptotes, again, we always need the rise over the run, the change in the y values divided by the change in the x values. And this is always a combination of our b over our a. So in this case, it's really teeny tiny to see, but we went up 2 units, so that's our rise, and we went to the right or left 1 unit. Okay, so our rise over run in this case is positive and negative 2 over 1, or just positive and negative 2. However you'd like to write that, and that is a over b. So whatever the change in my y is, that denominator, that a squared helps get me my a, and then my run is the b value. All right, and last but not least, to determine the foci, we're going to do c squared is a squared plus b squared. Remember, our foci should be outside past our vertices. So c squared is 4 plus 1, which is just 5. So that means c equals positive and negative square root of 5. And in this case, because we have a vertical hyperbola, we are going to add our c value to the y coordinate of the center. So our center was the point 0, 0. So I'm going to have 0, comma, 0 plus and minus the square root of 5, or if you want to write that a little bit easier, you can just write 0, comma, plus and minus the square root of 5. Either of those two mean the same thing. This example, x squared minus y squared minus 4x plus 8y minus 21 equals 0, is in general conic form. So we are going to regroup our x and our y terms and move our constant value to the other side of the equation so that we can get it into standard form. So now that my x's are together, I can go ahead and complete the square for the x's. X squared minus 4x plus that c value. Half of negative 4 is negative 2, and negative 2 squared gives me a positive 4. For our y terms, you'll notice this is a negative y squared, so I do need to factor out that negative 1 in order to complete the square. So that would be negative 1 times y squared minus 8y plus, completing that square, half of negative 8 would actually be negative 4, and negative 4 squared would give me 16. And that will equal 21 plus the 4 that I added for the x's, and then minus 1 times the 16 that I completed the square with for the y terms. So in factored form, x squared minus 4x plus 4 gives me x minus 2 quantity squared, minus y squared minus 18 minus 8y plus 16 is y minus 4 quantity squared. And everything on the right hand side, the 21 plus 4 minus 16, all simplifies to give us 9. We then do need to divide every single term through by 9 in order to get our equation into standard form. So we'll have x minus 2 quantity squared over 9 minus y minus 4 quantity squared over 9 all equals positive 1. And the reason we do that again is so that we can get our center, which will be the opposite of the x and the opposite of h and opposite of k, so it'll be the 0.24. Then we can determine our a and our b values, the direction that our graph goes, and get our function sketched. So our center, I will go ahead and put up here at the 0.24. Since this does begin with an x squared, so x squared is first, and it is also the positive term, that means it is definitely going to be a horizontal hyperbola. And my a squared has to be first as well. So a squared equals 9, so my a value is 3. We are going to travel 3 units to the right and 3 units to the left of our center so that we can get our vertices. And those vertices are going to be the points -1, 4, as well as 5, 4. Our b value happens to be the same value as a because our b squared is the same as our a squared. That doesn't happen very often, but it's okay for that to happen for the hyperbolas. So from our center, we are going to travel up 3 units for a covertice and down 3 units for a covertice. So that puts our covertices at the points 1, 1 and 1, 7. Okay, we can connect these points, our vertices and covertices, with our little box so that we can find those corner points so that we can draw our asymptotes through the diagonals of this little box that we have. And that will help us make sure that we are approaching our asymptotes correctly when we sketch our hyperbola. As well as help us get the slope of our asymptotes. So I'm going to go ahead and sketch our function. It is horizontal, so I'm going to go on the vertices on the left and the right and sketch those curves as best I can and approaching those asymptotes. I'll then determine the slope of the asymptotes. Remember, this is always, always, always your rise over your run. So from the center, how far up do I travel? What is the distance from the center, in this case, to a covertice? 3. Okay, so my rise is positive and -3. Over my run, how far did I travel to the left and to the right to get to a vertice from the center? I also traveled 3. So this happens to be 3 over 3, which simplifies to give us a slope of positive and -1. And that's kind of nice. And last but not least, to plot our foci, we need to use our equation c squared equals a squared plus b squared. And when I add 9 plus 9, I'll get 18. And when we take the square root of 18, we will get both positive and negative 3 square root 2. This value, remember, is our distance we travel from the center out to plot a foci point, whether they are left and right for horizontal or up and down for vertical. So we need to add this c value in this example to the x coordinate of the center in order to plot our foci on the transverse axis along with our vertices and our center. So our foci are going to be the points 2 plus and minus 3 square root 2, comma 4. Great job, guys. In our last example, we are again in general conic form, so we are going to need to regroup our x's and our y's so that we can complete the square and get our equation into standard form. And I'm going to do a couple of things at the same time for this particular example to save a little bit of space in my slide. So I have 16x squared minus y squared minus 32x minus 6y equals 57. I'm going to go ahead and group the x terms together as well as factor out that leading coefficient of the x squared. So 16x squared and negative 32x have that 16 in common. So that leaves me with 16 multiplied by x squared minus 2x plus, fill in my little blank for completing my square, For the y squared term and the y term, I do need to factor out the -1 before I complete that square, so that I can make it a positive y squared, or in order to complete it. So y squared and then -6y will turn into a positive 6y plus my little blank to complete my square. And that equals the 57 that's already over here plus 16 times whatever I complete my square with minus 1 times whatever I complete the y squared terms with. So completing the square for the x's, half of -2 is -1, and 1 squared gives me +1. So I'll put that in on both sides of my equation. For my y values, half of +6 is 3, and 3 squared gives me 9, so it's -1 times that 9 on the other side of the equation. Okay, so this leaves me in factored form with 16 times the quantity of x minus 1 squared. The next part would be minus, and you can put the 1 there if you need to. Y squared plus 6y plus 9 would be y plus 3 quantity squared. And when I combine all my like terms on the right hand side, I have 57 plus 16 and then minus 9. So that will give us a total of 64. So the entire equation equals 64. And as we've done with all ellipses and hyperbolas, we need to divide through by that constant in order to write the equation in standard form, all equal to 1. So we will be left with, let's see, x minus 1 quantity squared all over 4 minus, nothing simplifies with the y's, so y plus 3 quantity squared over 64, all equal to 1. Okay, so in this example, you should notice that our a squared is, remember, that's always going to be first. That's always true. But in this case, it's definitely smaller than our b squared term, and that's perfectly fine. So a squared is under the x squared, making this a horizontal ellipse. Again, another horizontal one. So if a squared is 4, our a value will be 2. And our b squared value is going to be 64. So the square root of 64 would give me 8. And I'll travel up and down 8 units from our center. And in fact, our center is the point 1, comma, -3. And that was the opposite of my h and opposite of my k value. So I have the point 1, -3 as my center. And from there, I'm going to travel 2 units to both the right and the left in order to get my vertices. And I'll list those as -1, -3, and 3, -3. From the center, I need to travel up and down 8 units in order to determine the height of our graph and get our covertices. So I'm going to travel down 8 units. This one's actually going to be off the graph. That's okay. And then we'll travel 8 units up from there to get the other covertice. So my covertices actually land at, let's see, where am I? 1, 7 is up top, and 1, -11 is at the bottom. Excuse me, it's actually, the covertice is at 1, 5. Excuse me, I added wrong. 1, 5. There we go. 1, 5 and 1, -11. So the total distance for that conjugate axis is 16 units, and the total distance for our transverse axis, which is going to include the vertices, center, and the foci once we get them, that only has a distance of 4 units. All right, so in this case, sketching our little box, we're going to notice that this guy is going to have a really steep slope for our asymptotes. So we are always looking again at the rise over the run. So we're looking at the change in the y values over the change in the x values, and from the center up to this covertice, that total distance of B is 8. And from the center over to a vertex, or one of the vertices, is a distance of 2. So we are going up and down 8 over 2, which would give me both positive and negative 4. So the slope of our asymptotes is 4 or 4 over 1, however you would like to actually write that. Okay, so we are going to sketch those asymptotes as best we can so that we can then sketch our hyperbola. And again, this one is horizontal. So from these vertices, I'm going to go stretch way up and over in order to try to get close to those asymptotes. And there we go. There's our graph. Last part is to get the foci. C squared is a squared plus b squared. So we have c squared equals 4 plus 64, which is 68. And the square root of 68 gives us both positive and negative. That's 4 times 17, so 2 square root 17. And this value, again, we are going to add our c value to the x coordinate of the center because we have a horizontal hyperbola. So our foci are going to be the points 1 plus and minus 2 root 17, comma, negative 3. And that distance is actually going to be pretty far out from our center. So square root of 17 is about 4, so we're going to go just over 8 units out from the center and put our foci. So they're going to be way out here somewhere. Oops, writing that backwards. There you go. And that's just a rough sketch of where those points are going to be. Hope you guys have had a good time through this lesson and that you're getting the pieces kind of they're falling into place for the hyperbolas and connecting them with those of the ellipses. Make sure that you're practicing some problems on worksheet E.